Hello and welcome to Excellence Academy. Alright, so let's take an 8th example. Let's learn how to differentiate this. Y equal to what you see here. For this question here, my predominant method will be chain rule. Chain rule because I can see a high power here. So instead of use chain rule, we know you're having a rational index or a very high index or power. So this is 4. So the predominant method here is actually chain rule. But also, while we're using chain rule there, if I look at this, I can see that this one here, 3x squared plus 2, is dividing exponential 3x minus exponential x. So hence, there's a bit of quotient rule differentiation here due to the division. So this is more like a combination of quotient rule and chain rule differentiation. Let's work on this there. For chain rule, I will say let u be equal to the term here, term in the bracket here, that's 3x squared plus 2 all over exponential 3x minus exponential x. If I'm to differentiate this one here, using quotient rule, using quotient rule, I'll have that du over dx, du all over dx is equal to, so this more like du, this like v. So quotient rule is v du over dx minus u dv over dx all over v squared. So start with this first, v exponential 3x minus exponential x into differentiate this one here. If I differentiate this now, I'm having 6x minus this one here, that's about 3x squared plus 2 into differentiate my denominator here. That should give you, this one gives you 3 exponential 3x minus differentiate exponential x, you get exponential x. This all over v squared. So this one here, all squared, that's exponential 3x minus exponential x all squared. So I have this case here. Any like terms? Not really. This and this are not like terms because I can see 3 attached to this. There's no 3 here. So they are not really like terms. So what you could do here is that you could choose to expand this if you want to. Yeah, choose to expand this and then collect like terms. But that will be looking very complex. So I'll just leave it this way, and instead I will say y. Also, I have that y is equal to, we just said all of this should be u, that's this should be u. So y becomes all of this, which is u now, becomes u to power 4 here, so to power 4. If I differentiate y with respect to u, I will have that dy all over du is equal to, this one gives you 4u to power 3. Alright, so if I combine my quotient rule answer then with this one here using chain rule, so using chain rule, we have that dy over dx, we have that dy over dx is equal to dy over du times du over dx. So dy over dx is now equal to, dy over du is this 4u to power 3 times du over dx, which is all of this. And so that should be something about exponential. This is into exponential 3x, that's this, minus exponential x, this into 6x, this one here, minus this term here, that's 3x squared plus 2 into all of this 3x, 3 exponential 3x minus exponential x, this one here, into all of this all over this square. That should give about exponential 3x minus exponential x, this all squared. So I have this. To create space now, take this one off. So taking this off to create space. Taking this off now to create space. I have this as but we already said that u is equal to, here's the value for u. That gives you about 3x squared plus 2 all over exponential 3x plus minus exponential x. So hence I'll have that dy over dx, have that dy over dx is now equal to 4 into u, that's 4u cubed. U itself is 3x squared plus 2 all over this exponential 3x minus exponential x. So 4u cubed into all of this. This term here is now 3. That gives you exponential 3x minus exponential x into 6x minus 3x squared plus 2 into 3 exponential 3x minus exponential x, this one here, all over v squared. My v here is exponential 3x minus exponential x all squared, to create up this one here. So I have this. So this is like your answer. You could choose to expand and simplify if you want to, but this is like the answer to this differentiation. Okay, so let's look at the 9th example. Let's say I'm giving y being equal to what you see here, and I'm asked to find dy over dx here. I'm asked to differentiate this. Just like, for example, 8. This is a combination of chain rule, for the fact that it has a high power, and also quotient rule, because this is dividing, or these two they are dividing themselves. Alright, so in that regards, I'll have to combine the idea of chain rule and quotient rule. So case 1, I will take u, I will say let u be equal to the term in the brackets there, that's 2 exponential x plus 5 all over what you have here, 6x to the power 5 minus 3. Next up, differentiate u. I'll have that du over dx is equal to, for this differentiation I'll have to use quotient rule, since this is dividing this. So I'm using quotient rule here. This now becomes v, that's 6x to the power 5 minus 3. Next up, differentiate this. If I differentiate this, it gives you 2 exponential x. Of course, 5 is 0, so it's off, minus the numerator for u. So I'm having 2 exponential 5 x plus 5, 2 exponential x plus 5 into differentiate this. If I differentiate this one, you get this, and this gives you 30. Gives you 30x to the power 4. 5 minus 1 is 4. Constant is off, so I'm having this case here. This all over. So all over. Work on this, becomes v squared. So I'm having 6x to the power 5 minus 3 all squared. Any like terms? Not really. Just to expand this, as I said, but I'm not expanding this, I'll leave it this way. Next up, but y is now equal to, we call all of this u, so y becomes u to the power 1 there, 7. Okay, differentiating y with respect to u, I have that dy all over du is equal to, if you differentiate this, it gives you 7u to the power 6. To the power 6 as you have here. Alright, so next up, using so this one's done using quotient rule. Now using chain rule, my paramount method here, using chain rule, what do I have? I have that dy all over dx is equal to dy all over du times du all over dx. This is now equal to, okay, equal to dy du is this thing here. Okay, dy du is this 7u to the power 6 times du over dx is this one here. That should be about 6x to the power 5 minus 3 into 2 exponential x minus 2 exponential x plus 5 into 30 x to the power 4. This all over this one here, 6x to the power 5 minus 3 all squared. So I have this. Okay, so to take off this one here, to create space, I'll take off part of this, of the create space for what's coming. Okay, I have this. Next up, but we just said u is equal to this 2 exponential x plus 5 all over 6 x to the power 5 minus 3. So if I substitute the value of u here, I'll have that dy over dx is equal to 7 into u. U is 2 exponential x plus 5 all over this 6 x to the power 5 minus 3. So 7u to the power 6 to the power 6 here. 7u to the power 6 into all of this. So into all of this here. That gives you 6x to the power 5 minus 3 into 2 exponential x minus, this is 2 exponential x plus 5 into 30x to the power 4 all over this one here. That gives you 6x to the power 5 minus 3 all squared. So I'm having this case like this. So this now becomes the answer to that differentiation. Alright, let's take a 10th example. Let's say I'm given y is equal to x root x, that's x times root x minus 2 all over x cubed plus ln x. And I'm asked to differentiate y with respect to x, or perhaps find dy over dx. What do I do here? Case one, each of them has their different, each of these terms, that's this, have their different methods of solving them. So case one, I'll put this one here in index form. So I'll have that y is now equal to x into, this is x to the power 1 over 2 from the idea of indices, okay, minus, this is now 2 all over x cubed plus ln x. Alright, work on this now. For this one, I'll use product rule because they are multiplying. That's an alternative to you using index method. By index method, I mean you could say x times x power 1 over 2. This is power 1 here. So this will be x into same base multiplying, add the powers. It becomes 1 plus 1 over 2. And this will now give you x to the power 1 plus 1 over 2 gives you 3 all over 2. So this will be your answer on multiplication, such that if y is equal to this, if I differentiate this now, it's now be equal to, using general method, gives you 3 all over 2 x into 3 all over 2 minus 1. Okay, so this now gives equal to 3 over 2 x into, work on this one here. So this gives you 1 over 2. That should be your answer. Yep. So this is more like saying 3 all over 2 times x power 1 over 2 is root x. So it gives you equal to 3 root x all over 2. That's using your idea of indices or general method. You can still use product rule here. So I'll use product rule for this one here. Now take this one separately. From here I'll have that dy all over dx is now equal to, before I get to dy over dx there, let me first of all simplify this. If I simplify this one here, it becomes y is equal to x into x power 1 over 2 minus, I'm taking the 2 outside, it gives you 2 times 1 all over x cubed. So 2 times 1 gives you 2 here. So plus ln x. So I took away the 2 here. So 2 times 1 gives you this 2. Just separating them. Write this one now in index form. I'll have that y is equal to x into x to the power 1 over 2 minus 2x into, this in index form is minus 3 plus ln x. Alright, so I've simply changed this from the equation from this form to this form, and it's the same thing. Work on this one now. I'll have that dy over dx, dy over dx is now equal to, since these two are multiplying, I'll use product rule for this one here. So it gives you v, so this becomes u is x, v is now all of this here. So it gives you v is x power 1 over 2 du over dx, u is x, du over dx is 1 plus u is x into dv over dx. If I differentiate this using general method, my first task is to multiply by the index, then subtract 1 over 2 minus 1. Alright, so it gives you v, that's all of this here, v, that's x power 1 over 2, okay, into, this is u, du over dx is 1 plus u, that's this, into dv over dx. To differentiate this, it becomes this. So I'm having this one here. To differentiate this one here, the idea will now be multiply here by minus 3. So that's using general method, becomes minus 3 times everything you have here, minus 2 x to the power minus 3 subtract 1 minus 1 plus, if I differentiate in x, I get 1 all over x. So you have this. Alright, work on this now. This is now equal to x to the power 1 over 2 times 1 gives you x to the power 1 all over 2. Next up, plus, if I work on this gives you x into, all of this is equal to 1 over 2 x to the power. This gives minus 1 over 2. Minus times minus is plus. 3 times 2 is 6x into minus 3 minus 1 is minus 4 plus 1 all over x. I have this. Work on this now. This will now be equal to x to the power 1 over 2 plus, if I multiply these ones here, this should now give something of x times this. So x times 1 is x. X times this gives you x multiplying, the power here is 1. So 1 plus, okay, let me do it this way. X times 1 is x. X times this, it becomes times x bar minus 1 all over 2. All over 2, right? X times 1, that's x here. Then times this one here, that's this all over 2. So this plus 6x to the power minus 4 plus 1 all over x. So I'm going to work on this now. I'm now having this as being equal to, this will give me x power 1 over 2 plus, they are multiplying, so you add the powers. If I add the powers, it gives you x to the power, this is 1, alright, 1 minus half gives you 1 over 2, alright, all over 1 there, all over 2. So I have this here, this now gives you this, plus, this one gives you 6x to the power minus 4 plus 1 over x. This is now equal to, if I take LCM here, this over 1, so the LCM of 2 and 1 is now 2. 2 divided by 1 is 2. 2 times this is itself 2x power 1 over 2 plus this over this, 2 over 2 is 1. 1 times this is x power 1 all over 2 plus 6x power minus 4 plus 1 all over x. If I work on this, we know that 2a plus a is equal to 3a. That means if 2 of a term is adding that same term, it gives you 3 of that term. Hence, if 2 of x power 1 over 2 is adding x power 1 over 2, the same term, it gives you 3 of it. So it becomes 3x to the power 1 over 2. These 2 here, all over 2. I have this. Okay? Plus, pick up this one here. So plus, this gives you 6x power minus 4 plus 1 over x. I can write this in index form as being equal to 3. X power 1 over 2 is root x all over 2. And observe, this is the same answer as when I used my general method initially. So it's the same answer. Just like I had to take the longer method so that you could see alternative ways of doing it. So at this point here, you can use product rule as I did here, and you still have the same answer as if I combine them initially as I did using general method, the same answer. So I have the same thing. Alright, so I'm having this, so it's now equal to this one here is this plus 6x power minus 4 plus 1 all over x. So this is your answer if I differentiate this term.